Okay, sorry this is two videos. My videos stopped working, and so this is just the second part of it. For these two examples, we're going to be drawing two different reference triangles and using like the values that are given. So it tells us that the cosine of A is really -1/5, and the sine of B is 3/5. So this is talking about one angle, and this is talking about another angle, which means that we're dealing with two different reference triangles. So we're going to draw a picture for angle A, and we're going to draw a picture for angle B. It tells us that angle B is in quadrant 2. So here's my reference triangle in quadrant 2. And it tells me that the cosine of A is -1/5. So if I'm going to put that in my triangle, cosine is my adjacent over my hypotenuse. So that would be what my triangle looks like in quadrant 2. Since I'm looking for the cosine of A plus B and the cosine of A minus B using my sum and difference, I'm going to end up needing the sine. So we can find the sine of A as well. If I do that, I have to use my Pythagorean theorem to solve. So I'll call that my y value. So get 1 plus y squared equals 25. So y squared equals 24. Take the square root. And we'll simplify. So 24 is 8 times 3 or 4 times 6. So I can take the square root of 4 and get 2√6 for my answer there. So this side length is 2√6. So my sine would be 2√6/5. So that's at least my reference triangle for A, and reference triangle for B. A is in quadrant 2 and B is in quadrant 2. So we're in quadrant 2 again. So I'm going to label this as angle A, and this is going to be angle B. The sine of B, opposite over hypotenuse. This one's nice. And then this would be on my missing side length, so that's -4. So my sine of A is 3/5, and my cosine of A is -4/5. And again, the reason I'm doing that is I need to come up with my sum and difference identities. So I need to find the cosine of A plus B and the cosine of A minus B. And each of these are using the identities that we had on the front. So cosine of A, cosine of B, minus sine A, sine B. And the other one, cosine A, cosine B, plus sine A, sine B. Now, since these are pretty much identical, our cosine of A minus B is going to be pretty easy to find because all we really have to do is switch the sign. So once we evaluate and figure out all these pieces, then it's pretty easy to actually simplify. Now, I already know, because we already found these reference triangles, and we found the sine of A, and we found the sine, these should say B. I'm sorry, guys. That's what my angle is. We already found the sine of A and cosine of A, and the sine of B and the cosine of B. So now I just have to replace cosine of A, cosine of B, sine B with all these different values. So the cosine of A is -1/5. The cosine of B is -4/5. The sine of A is 2√6/5. And the sine of B is 3/5. So we get 4/25 when we multiply across here, minus 3. When we multiply these two things, we multiply the whole number. So it's 3 times 2, which is 6, √6 all over 25. And we can put that in one fraction and get 4 minus 6√6 all over 25. We should double check to make sure that that can't be simplified more, like common factor in the top and bottom, like if I can divide everything by 2, but this one we can't, so we're just going to leave it like that. And then the cosine of A minus B is pretty similar. We have all the same values that we had above. Like we have the cosine of A is still -1/5. We have the cosine of B is still -4/5. We have the sine of A, which is 2√6/5, and the sine of B is 3/5. And all together, when we simplify that in one fraction, it's exactly the same values. The only difference is that we have a plus here instead of a minus. These ones you can't check with your calculator, but we could like maybe try, if we wanted to, we could like come up with an inverse for these ones and come up with the angle and then like actually calculate it and see if it matches. It's harder to check it with those, but most of the time we just kind of leave it like this with our simplification. It's important to know that like cosine of A is actually a ratio, so that is the fraction of 1/5. A lot of people try to put A as like 1/5 and B is like 3/5, and then you're trying to evaluate the cosine of 1/5 or cosine of negative 1/5 and the cosine of 3/5. A and B are angles. These are ratios. So the cosine of A evaluated at that angle A is a ratio of negative 1/5. So there's a distinction there. Next one, same idea. So you might want to pause it and try this one because this is pretty much the same problem. It's just looking at different numbers. So it might be a good practice for you. Again, we are looking for cosine of A plus B and the cosine of A minus B. And for both of these, we're using our identities. So cosine of A, cosine of B, minus sine A, sine B. And this one, cosine A, cosine B, plus sine A, sine B. And then for, again, our reference triangles, we're going to have two angles that we're dealing with, A and B. So we're going to draw two reference triangles. It tells us that the sine of A in quadrant 2 is 2/3. And that means that our leftover piece, so we get 9 minus 4 is the square root, is 5. Take the square root, so it's root 5. So sine of angle A is 2/3, and the cosine of angle A is root 5/3. Okay, I'm gonna like come back to that, so I'm gonna box it so that way when I go ahead and replace all these things inside my cosine of A plus B and cosine of A minus B, I have these values already. And it says that B is in quadrant 4. So this again is angle B. It says that sine is negative 1/3. So we can find that missing length, x squared plus negative 1 squared equals 3 squared. So we'll get 9 minus 1, so root 8, which we can reduce down. That's 4 times 2, so 2√2. So if I were going to come up with my sine of B and cosine of B, I already know the sine is negative 1/3, and my cosine, we just found that value of 2√2/3. And so now I replace those values in my sum and difference. So the cosine of A is root 5/3. The cosine of B is 2√2/3. The sine of A is 2√3. The sine of B is negative 1/3. So I simplify. I get 2. Root 5 times root 2 is root 10 over, 9, not 3. And then minus 2 times negative 1, so that's going to be a plus 2/9. So altogether, 2√10 plus 2/9. For our answer for that one, for the cosine of A plus B. And for the cosine of A minus B, again, all of our values are exactly the same. The only difference is that we have a plus here. So we'd still have this 2/3, we'd have a negative 1/3, we'd have this root 5/3 and the 2√2/3. So we would still get, again, 2√10/9. And in this case, instead of minus and a minus, making a plus here, we have a plus and a negative, so we'll have a minus 2/9. So 2√10 minus 2 all over 9. Okay.